Combination of resistors. 1. In series. I equivalent resistance R equals R1 plus R2 plus R3. E current through each resistor is same. Sum of potential differences across individual resistors is equal to the potential difference applied by the source. 2. In parallel. Equivalent resistance. 1 R equals 1 R1 plus 1 R2 plus 1 R3. Potential difference across each resistor is same. Sum of electric currents flowing through individual resistors is equal to the P electric current drawn from the source. Electric cell. An electric cell is a device which converts chemical energy into electrical energy. Electric cells are of two types. I primary cells. Primary CS cannot be charged again. Voltic, Daniel and Leclanché cells are primary cells. Secondary cells. Secondary cells can be charged again and again. Acid and alkali accumulators are secondary cells. Electromotive force EMF of a cell. The energy given by a cell in flowing unit positive charge throughout the circuit completely one time is equal to the EMF of a cell. EMF of a cell A equals WQ. Its SI unit is volt. Terminal potential difference of a cell. The energy given by a cell in flowing unit positive charge through till outer circuit one time from one terminal of the cell to the other terminal of the cell. Terminal potential difference V equals WQ. Its SI unit is volt. Internal resistance of a cell. The obstruction offered by the electrolyte of a cell in the path of electric current is called internal resistance R of the cell. Internal resistance of a cell. I increases with increase in concentration of the electrolyte. E increases with increase in distance between the electrodes. E decreases with increase in area of electrodes dipped in electrolyte. Relation between E, V and R. A equals V plus IR. R equals A, V1 R. If cell is in charging state, then A equals V IR. Grouping of cells. I in series. If n cells each of EMFA and internal resistance R are connected in series to a resistance R, then equivalent EMF. EEQ equals E1 plus E2 plus N equals N. Equivalent internal resistance V equals R1 plus R2 plus Rn equals NR. Current in the circuit I equals EEQ R plus V equals N R plus NR. In parallel, if n cells each of EMFA and internal resistance R are connected to in parallel, then equivalent EMF. EEQ equals A. Equivalent internal resistance. 1 REAC equals 1 R1 plus 1 R1 plus 1 Rn equals NR or REAC equals Rn. Current in the circuit I equals A R plus Rn. Mixed grouping of cells. If n cells each of EMFA and internal resistance R are connected in series and such M rows are connected in parallel, then equivalent EMF EEQ. Equivalent internal resistance V. Current in the circuit I equals N R plus NR per meter. Or I equals MNE, Mr plus NR. Note, current in this circuit will be maximum when external resistance is equal to the equivalent internal resistance, i.e. R equals NR per meter, Mr equals NR. Kirchhoff's laws. There are two Kirchhoff's laws for solving complicated electrical circuits. I junction rule. The algebraic sum of all currents meeting at a junction in a closed circuit is 0, i.e. sigma I equals O. This law follows law of conservation of charge. Loop rule. The algebraic sum of all the potential differences in any closed circuit is 0, i.e. sigma V equals 0, sigma A equals sigma IR. This law follows law of conservation of energy. Balanced Wheatstone bridge. Wheatstone bridge is also known as a meter bridge or slide wire bridge. This is an arrangement of four resistance in which one resistance is unknown and rest known. The Wheatstone bridge is shown in figure. The bridge is said to be balanced when deflection in galvanometer is 0, i.e. Ig equals O. Principle of Wheatstone bridge. VQ equals RS. The value of a known resistance S can found as we know the value of VQ and R. It may be remembered that the bridge is most sensitive when all the four resistances are of the same order. Meter bridge. This is the simplest form of Wheatstone bridge and is especially useful for comparing resistance more accurately. Rs equals L1, 100 L1, where L1 is the length of wire from one end where null point is obtained. Potentiometer. Potentiometer is an ideal device to measure the potential difference between 2 points. It consists of a long resistance wire AB of uniform cross-section in which a steady direct current is set up by means of a battery. If R be the total resistance of potentiometer via L its total length, then potential gradient, i.e. fall in potential per unit length along the potentiometer will be K equals V, L equals IRL, equals AO R rho plus RL, where AO equals EMF of battery and rho equals resistance inserted by means of rheostat RH. Determination of EMF of a cell using potentiometer. If with a cell of EMF A on sliding the contact point we obtain zero deflection in galvanometer G when contact point is at J at a length I from the end where positive terminal of cell have been joined, then fall in potential along length I is just balancing the EMF of cell. Thus we have A equals Kn, or E1, E2 equals L1, L2. Determination of internal resistance of a cell using potentiometer. The arrangement is shown in figure. If the cell A is in open circuit and balancing length L1, then A equals KL1. But if by inserting K2 circuit of cell is closed, then U10 difference V is balanced by a length L2 of potential where V equals KL2. Internal resistance of cell. R equals A, V, V, R equals L1, L2, L2 asterisk R. Important points. Potentiometer is an ideal voltmeter. Sensitivity of potentiometer is increased by increasing length of potentiometer wire. If n identical resistances are first connected in series and then in parallel, the ratio of the equivalent resistance Rs Rv equals N2, 1. If a skeleton cube is made with 12 equal resistance each having a resistance R, then the net resistance across the diagonal of cube equals 5/6 R. The diagonal of a face equals 3/4 R. Along a side equals 7/12 R. If a resistance wire is stretched to a greater length keeping volume constant, then RL2 R1, R2 equals L1, L2 2. And R1, R4 R1, R2 equals R2, R1 4. Where L is the length of wire and R is the radius of cross-section area of wire. Thank you for watching my video. Please like, comment, share and also subscribe to my YouTube. Subscribe and please press the bell icon for latest science lecture updates.